Hi guys, bit of a rambling video this, just playing with bits and pieces. I've actually just finished the video, but I just thought I'd do this introduction. So I've got a couple of coils here out of a small transformer. I don't know what the voltage was. It would have been 220 volts in on this coil, but I don't remember what it was, what the output was. Really doesn't matter. That coil worked, this coil didn't, and this one, well, you'll see why it didn't when you watch the video. But that's all this video is about. It's not about the pulse motor as such, it's just me playing around with bits I found in the junk box. Hi guys, been going through my scrap box again. Quite a while ago I disassembled, I don't remember what it was, but it had a small wall wart, as the Americans call them, small power unit to drop the voltage from mains voltage to, I don't know, 12 volts, something like that. Anyway, the transformer itself was 40. Now, rambling here, but I found it again, took it apart, took the coils out of it. One of them is good, so I've stuck it on that pulse motor. Go on, you can do it. Just go a little bit further. Yeah. So that's quite happy. Oh, I see why it stopped. The magnets are actually knocking the side of the... Yeah, that's better. Magnets were knocking the side of the frame there, and it's tapping away. Anyway, yeah, that works. It's doing it again. Must be tilted. That's using a reed switch or reed relay there to receive the magnet as it goes past, and that triggers a BD135. So the actual power is coming through this BD135 to pulse the magnetic, or pulse the current to create a magnetic field, and as you can see, that's spinning beautifully. Anyway, that's all a bit of a side issue. What I was interested in is the other coil is dead. You can probably guess from the thickness of the wires that go to it. This is the mains power side of the transformer, and it's disconnected. If I go straight across there, I get the tone, and if I go across the coil, I get nothing. So I thought I'd have a look at the coil. I've started stripping the blue plastic tape off it, and I can actually see what I expected to find, which is a thermal fuse just here. If I can get to it. So I'm betting that if I bypass that thermal fuse, let's zoom in on it. There we are, thermal fuse. If I bypass that, I expect I've probably got a good coil here as well. So one end of that is probably going to that lead, and the other end is on the thin wire there, which is the coil. So if I go on this side of it, yeah, that's the direct connection to this side of the fuse. Didn't show that very well, did I? Let's do that again on there. Yep. And if I go on the other side of it, which will be there, should get nothing there. Yeah, and I should get current here. Current. If I can make contact. Right. So on the other side of it, and we should, of course, the coil itself may be burnt out, I suppose. Which is why the thermal fuse would have blown. But I'm rather hoping it just overheated and blew the thermal fuse. No. Oh, that's a shame. I wanted to do that live on camera and say, oh look, I found the way round it. Not so much the fault, but found the way round it because we can bypass the fuse. But nope, that's not doing it. So that means the coil is dead somewhere. Gosh, I wonder how that overheated that much. Because that wire may be disconnected, like it is. No, I wonder if we can find the other end. Alright, I'll stop filming and do a bit of searching. Well, I'm not sure, but I might be really lucky. I can just see a little bit of wire sticking up just there. If I go on there and go on there, we've got about, well, we've got something. Let's measure the resistance. Go on a 2K scale. $20K. $2K. 1.48K coil. So we might be all right if I can get a bit of solder on the end of that bit of wire. We might have a working coil that I can use for a pulse motor or something. Right, got a bit of solder on there. Okay, 1.48K. So what I'll do now is put a bit of hot glue on there to try and protect it. So I'm heating up the hot glue gun to do that. Right, my usual test to see if we've got a working coil. Just put a magnet on it and pass some current through it. Yeah, so we have another little coil. I don't know what I'm going to do with it. I suppose ideally another pulse motor. Right, here's a nice useless use for that coil. I've just soldered two LEDs in opposite direction, so they'll light up whichever way the current is flowing. If we hold that next to this spinning wheel, can we see those are lighting up? Only just. There we go, so we're generating electricity with that coil. And the coil is being powered by the magnets spinning there, which are being powered by that coil, which is that battery. So we're putting about 7.5 volts in and getting millivolts out. Very efficient. Still, it works. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.